Today we look at a little bit of sequences slash patterns. And we're going to talk about two different types, right, east down. We've got a pattern that's going to look like this: 3, 6, 9, 12, dot, dot, dot. And then we've got one that looks like this: 1, 3, 9, 27, dot, dot, dot. Whatever it is there. Now, the first thing to look at when we're talking about these are two different types of sequences. The first one, what are you doing between every number here? Brianna? Right. Well, back in the day we used to say plusing 3. You're adding 3. If it, between terms, if it is adding or subtracting, write this down because you're going to want to keep track of this, it is called an arithmetic sequence. Arithmetic sequence. And in addition to that, when you want to find out how to write the formula, if you are writing the formula, guess what you're going to do in your formula? Snap out of it. Guess what you would do in your formula? If I was writing a formula for this, to find the letter A, what is going to be in it? Well, don't guess, I'll just tell you. It's going to be multiplication or division, but let's go with multiplication. And before we even look at that one, I'm going to do this here. If you are trying to find out what a formula is for a sequence, the best thing that you can do for this is put this in a grid kind of thing. In other words, make this, put a box around this, put another level above it, split this like this, okay, and then start with this. Above up here, put the number 1, 2, 3, 4. Because this top column is the number of the term it is. The first term is a 3, the second term is a 6, the third term is a 9, the fourth term is a 12. The bottom of the box is what the value is. If you are writing a formula, it would look like this. What, and by the way, this, you always use the letter N for the top up there, as in the number of the term. Okay. If I want to find the bottom one, what if I asked you what the 8th term was? I kept this thing going without you having to do this. How could I find the 8th term of this? What would I do? What do I do to the top to get to the bottom every time here? What do I do to the top to get the bottom? And here's how it looked like. They always do their little terms like their letter A. This is, by the way, is A. The bottom one is the A, the top one is N. A to the nth term equals, what do I do to the letter N on top to get what it is? For example, what do I do to 3 to get 9? What do I do to 2 to get 6? 1 to get 3? I do what, Jaden? Multiply by 3. Here is your formula. No matter what the letter N is, you multiply it by 3. Whatever term it is, you multiply it by 3 and you get the bottom. So if it was the 8th term, it would be 8 times 3 and it would be 24 on the bottom. There is your formula. And that's what I mean, you would always multiply. Okay? Did you say it doesn't make any sense? Don't worry, because it's about to make a lot less sense here. Alright, looking at this one, if I were doing the same thing to that, here's where things get a little goofy, and you look at how you go from this to this to this. It's not very clear, but maybe it would be if you did this and put it in that same box there. You can box it up. Well, maybe you know. Actually, you can tell. What do I do to go from one term to the other term? What am I doing? Multiplying by 3. Sorry, you did catch that. Okay. If it's a multiplying thing, it's called a geometric sequence. It's called a geometric sequence. Now, if I know that, let me put these numbers in here and see if you can't figure out. Thoughts on what I do to the letter n, which is the number of the term, to get the bottom? What do I do to this to get this, that, or how do I get that from there? Who? Somebody? Come to the top of the 7th grade mental capacity here. Now, before you go on, let me give you the helpful little hint here. Geometric sequences are done using exponents. They're done using exponents. Okay? And it's done by this. Write this in your note. The number you are multiplying by is the base number. In other words, this. Here's my formula. The value of A equals whatever this number is here, that's my base number. And on top of here has to be some exponent. Guess what the exponent is? Actually, I did this one wrong, but I'll give it to you in a second here. Keith, the letter N. Now, here's where you're going to say, but that doesn't make sense. Not yet, it doesn't. What is 3? Let's put the 3 in here. If I make my n 3, what is 3 to the 3rd power? 3 times 3 times 3 is? I got 27, did I not? What if it was 2? What if I put my 2 in there? 3 squared is 9. What if I put 1 in there? 3 to the 1st power is 3. What do you notice? These are all off one place. Guess what you have to do in order to fix that problem? In other words, here, let me write here. A equals 3 to the n power we put there, right? But this, when I put 3 in there for this term, I actually got the 4th term. And when I put this 2 in there, I got this one. What can I do to fix this so that it matches up? What would I do to n? Instead of it being 3, I want it to be a 4. It's a tough one. What would you, if you have 3 and you want it to become a 4, what would you do to it? Add 1. And there is your formula. Okay, A equals 3 to the n plus 1. If I asked you for the, gosh, I don't even want to do it. If I asked you for the 5th term, you would have to take 5 plus 1. You'd have to take 3 to the 6th power. Anybody 3 to the 6th power? 3 times 3 times 3 times 3 times 3 times 3. Well, this is 27 times 27. Wait, that's not right. Oh yeah, it would be, because I'm going over here. You have to do that next one up there. 27 times 27, anybody? 49, 4, 14, 18, 27, We're about 729. Is that right? Let me give you another example. How about this? Let's say my sequence is this. And I asked you for the formula for that. Well, the first thing you have to do is figure out, the first thing you're going to do is make a box out of it, just so you can see it, so you can number your terms. First term is an 8, second term is a 6, third term is a 32, fourth term is a 64. The next thing you're going to do is figure out what are you doing between terms. What is this? To go from here to here, to go from there to there, to go from there to there. I'll walk you through this. What am I doing there? Emily? To go from 8 to 16, 16 to 32, 32 to 64, you are multiplying by 2. If I am multiplying, then it is a geometric formula, a geometric sequence. Always going to be solved like this. What did I just tell you? A to whatever power is. What do I know about this number 2? What is it? Just like in the last one. The number 3 was what? What's it say here? The number you are multiplying by is the base. So I go back here. I know my base number has to be 2. And I know my n goes up here. But I might have to adjust it. What is n to the first power? What is 2 to the first power? 2. 2 to the second power? 4. 2 to the third power? So this number here needed to be a 3, not a 1, because that's an 8. So what do I have to do to n to make it a 3? If 1 needed to be 3, what do you do to 1 to get to 3? So there's your formula. Does it work for the third term? 3 plus 2 is 5, is 2 to the 5th power 32? How about this sequence? How about one more, because I can tell you're mesmerized. 20, 25, 30, 35. Try to find the formula for that. Step number 1 is to do what? Isabel? Make a box around it. This is term 1, term 2, term 3, term 4. Number 2, figure out what do you do between terms. What am I doing between terms? Yeah, I'm adding 5. Now, when it's an adding one, it's an arithmetic sequence. That means in my formula, what is going to be? What did I just say about it in the last one we did? That was an arithmetic one. What type of it is? What type is it? Writing formula will be multiplication. And what are you going to be multiplying by? 5. So you know n is going to get multiplied by 5. But, ladies and gentlemen, does that work? Does 5 times 1 give you 20? No. 5 times what gives you 20? How do I get from 1 to be a 4, Jaden? Add what? 3. So you have to put a parenthesis around this because you have to add the 3 first. It has to be n plus 3. So if I wanted the 80th term, I'd have to take 80 plus 3 and multiply that by 5. Does that somewhat make any sense to you? If you have your notes and you follow the clear, concise steps, You will do it. I'm gonna give you one, and let's see if you can figure it out. Actually, I'll give you two. Four, 16, 64. And I'll leave it there because I don't want to go any higher. Write the formula for this sequence, and then this one. 32, 40, 48, 56. Write me the formulas for those two sequences. The formula. Follow the steps. Box them. Look what you do between terms. Figure out whether it's arithmetic or geometric. That'll tell you if you use exponents or if you just use multiplication. This is why you have notes and examples, because you will definitely need it for this. This is not for the faint of heart. Alright, in the interest of time, I have to cut you just a little short here. You got this. First of all, you go from this one to this one, and this one to this one, you did what? You multiply by 4. And we know that that's geometric, and we know that the multiplication thing is your base number. So you have to have 4 here, and it's going to be to some exponent. Okay, well, if I just put n here, and I make 1, is 4 to the first power 4? Yes, it is. Is 4 to the second power 16? 4 to the third power 64. So this one you don't have to adjust or shift the n because it's already right. This one here, to go from this to this to this, every time you are adding 8. So you know this is a arithmetic one. You're going to have an 8 here, and the n is. And the n is going to be here, but is 8 to the first term 32? No, 8 times what is 32? 4. So what do I have to do to 1 to make it a 4? Add 3 to it. So there's the shift that you need to figure out what your thing is there. Again, it's just a matter of having some clear, concise notes and you keep track there.